Good morning, batch 12. Good morning, guys. Welcome to CHI Online Training. Our subject for today is all about Electric and Electronics Fundamentals 3. And the lesson is all about RCL circuits. Let's start. Before going on, let's define what is RCL circuit or RLC circuit. So on the board, what is RLC circuit or RCL circuit? An RLC circuit is an electric circuit consisting of a resistor, an inductor, and a capacitor connected in series or in parallel. Now, this is the circuit of a series RLC circuit. And another one is the parallel. This is parallel RLC circuit. Okay? So these two circuits are different, as you can see on the picture. Okay? So your R1 here is connected to inductor, and the inductor is connected to capacitor, while the end of this capacitor is connected to the source voltage, and the other end of the resistor is connected to the source voltage. While parallel, both the upper terminal of RLC is connected directly to the source voltage, and the lower terminal of the RLC circuit are connected directly to the source voltage. So that is why the two circuits are different. Now, what is the application of the RLC circuit? Now, RLC circuit have many applications as oscillator circuits, radio receivers, and television sets use them for tuning to select a narrow frequency range from ambient radio waves. So that is the application of the RLC circuit. So you can find this circuit inside the radio receiver or television receiver. You can also find this circuit inside your cell phone. So that is why RLC are very important, okay, in electronic circuits, okay, and all electronic appliances or gadgets. Okay. Now, how do you solve RLC circuit? How to solve this? So let's start with a series RLC circuit. So as you can see on the picture, the circuit, your R, you can solve for the voltage in the resistor, and you can also solve for the voltage of this inductor, and you can also solve the capacitor voltage. Okay. And before you solve this voltage, you have to find first the current. What is the value of the current of this circuit? And before you find the current of this circuit, you have to solve the total impedance of this circuit. The total impedance is just like total resistance. But this, you cannot say resistance because there are three component which is different from each other. Okay, so we call that one impedance, and the unit of impedance is in ohms. Okay, so in solving the impedance, we have to use the formulas. Okay, we have to use formula. Okay, so first you have to solve for the inductive reactance of the inductor, which is called XL. Okay, so this is the formula. So XL is equal to 2 times pi. We know the value of pi, which is 3.1415, times the frequency, times the inductance. Okay. The next, you have to solve for the capacitive reactance, which is XC. So we will look for the XC of this capacitor. Then the formula is capacitive reactance, or XC, is equal to 1 over 2 times pi times F times C. Okay, next, solve for the impedance. Now, this is the symbol of impedance, which is Z. This is the symbol Z. Name impedance. And the formula is impedance, or Z, is equal to the square root of R squared plus, open parenthesis, XL minus XC, close parenthesis, squared. Okay, so this is the formula how to solve for the impedance. The next, you are going to solve for the total current, which is IT. So this time we are going to use the Ohm's law, but we are going to substitute the R into Z. Okay. So the formula is total current is equal to Vs, or source voltage, divided by Z. Okay. The next, solve for the voltage in resistor, which is called VR. The formula is VR, or resistor voltage, is equal to total current divided by the resistance. Next, voltage in capacitor, or VC. Formula is capacitor voltage is equal to total current divided by the capacitive reactance. Okay, this is XC. Next, solve for the total voltage in inductor, or VL. The formula is inductor voltage is equal to total current divided by inductive reactance. So we will use all of these formula to solve, okay, of these following questions. Okay, the XL, the XC, the impedance, the total current, the resistor voltage, capacitor voltage, and the inductor voltage. Okay, so let's have an example. Okay, by the way, we have to solve the power of this RLC circuit. So formula in solving the power, or true power, and reactive power, and the apparent power. So the formula of true power, this is the symbol of true power, is P is equal to I squared times R. And then the reactive power, and this is the symbol of reactive power, which is Q. The formula is reactive power is equal to I squared times, open parenthesis, inductive reactance minus capacitive reactance. Close parenthesis. Then, the apparent power, the symbol is S. Remember, S is apparent power. The formula is S is equal to I squared times Z. Okay? So this is how we solve for the power of this component. The resistor, the inductor, and the capacitor. Okay? So let's have an example problem. Okay? So series RLC circuit example problem. So a series RLC circuit containing a resistance of 12 ohms, an inductance of 0.015 Henry, and a capacitor of 100 microfarad are connected in series across a 100 volts source voltage and a frequency of 50 Hz supply. Calculate the total impedance, the circuit current, power factor, and the voltage of each components. Okay, so this is the circuit. So we have here R is 12 ohms, L is equal to 15.15 Henry, and capacitor, the capacitance is 100 microfarad. The source voltage is 100, the frequency is 50 Hz. So let's solve. Inductive reactance, XL, the formula of XL is XL is equal to 2 times pi times F times L. So substitute the value of pi, frequency, and L. So this is now the value. 2 times pi, which is 3.14, times 50 times 0.15 Henry is equal to 47.13 ohms. Let's continue. So, capacitive reactance formula is XC is equal to 1 divided by 2 times pi times F times C. Substitute the value of pi, F, and C. So, 1 divided by or over 2 times pi times 50, which is the frequency, times 100 microfarad. Okay, which is equal to 31.83 ohms. The next, we are going to solve for the circuit impedance, or the total impedance. So the formula is Z is equal to the square root of R squared plus open parenthesis XL minus XC close parenthesis squared. Substitute the value of R, XL, and XC. So the square root of 12 squared, this is your R, the value of R, plus open parenthesis 47.13, which is your XL, minus 31.83, which is your XC, then close parenthesis squared. So what is the value of this? So 12 squared is equal to 144 plus 47.13 minus 31.83 squared, that is equal to 234. Then you add these two, sum up, then square root, which is equal to 19.4 ohms. So this is now the impedance value of your the Z. Okay, so 19.4. The next, we are going to solve for the current of the series RLC circuit. Okay, so this is the formula. Okay, so circuit current, which is I. So the formula is I is equal to the source voltage divided by the Z. So your Vs is 100 volts, this one, and the Z is 19.4 ohms. So which is equivalent to 5.15 ampere. And then the voltage across the series RLC circuit, the VR, the VL, and the VC. This is resistor voltage, inductor voltage, and capacitor voltage. So VR is equal to I times R. Remember your R is this one, 5.15 ampere. Okay. So or 5.14 or 5.15 ampere. 5.14 times 12, that is equal to 61.7 volts. Then your VL is equal to I times XL. So that is equal to 5.14 times 47.30, that is equal to 242.2 volts. Then your VC is equal to I times XC, which is equal to 5.14 times 31.8 is equal to 163.5 volts. Okay, so this is how you solve for the voltage. Okay, then we have here the circuit power factor and phase angle. So this is cosine theta, which is equal to R divided by Z. Substitute R, which is 12. Z is 19.4. Sorry. Okay, which is equal to 0.619. Okay, so cosine theta is equal to 0.619. Then we have to get how to get the degrees. Okay, so you just only inverse the cosine theta times 0.619, that is equal to 51.8 degrees lagging. Okay, so 51 degrees going up like this. Okay, so this is the degrees, the value of the degrees or phase angle. We call this one phase angle, 51.8 degrees. Okay, next, how to solve for the power factor. So same problem, but this time we are going to solve for the power factor. So throw power is equal to I squared times R. So we will going to substitute I is equal to 5.15 squared times 12 is equal to, the power is equal to 318.27 watts. Next is the reactive power. So reactive power, the symbol is Q. So the symbol, the formula is Q is equal to I squared times, open parenthesis, XL minus XC, close parenthesis. Substitute the value of I, XL, and XC. So Q is equals to 5.15 squared times, open parenthesis, 47.13 minus 31.83, close parenthesis. And Q is equal to 405.79 VER, which is also the same as 1. Next is the apparent power. Okay, so apparent power, the symbol is S. So S is equal to I squared times Z. So next, substitute the value of I squared and Z. So 5.15 squared times 19.4, your apparent power is equal to, okay, so 514.54 VA. So this is how you solve for the true power. Okay, and the current that we have seen before, how to solve for the voltage and the current and the impedance. Okay, so this is the example on how to solve for the RLC circuit, how to solve for the impedance, the XL, the XC, the current, the voltage, and also the true power. Okay, so that's it, Shabab, for the guys. That's all for the series RLC circuit. Thank you. And after this is parallel RLC circuit.